Okay, today we're going to be talking about section 9.3. We want to be talking about, this can be called a lot of different things. One thing that we can talk about is when it's small dependent samples. We're going to collect two samples and we're going to have ordered pairs. Another way that you can think of it is that the subjects are going to be paired or matched together, right? So sometimes you're going to be seeing it called a matched pairs t-test. That's one way that it can be called. If you think about it, what we're going to be doing is we're going to be doing averages still. All right, so that's an important thing to do, and we're going to be pairing up like ordered pairs. A lot of times this comes as a before and after situation. Okay, before you run, before you join like a running program, you weigh this much. After you're in the running program for 5 months, you weigh this much. Was there a change in how much you weigh? So what we would do is we would then subtract all of those weights. Your before weight, your after weight, figure out what the difference is. Before weight, after weight, figure out what the difference is. And see if when you average up the differences for all the people, if they're going to be the same or different or less or greater or whatever you're trying to test. So you'd have like two data sets, but instead of averaging up everyone's before weights and everyone's after weights, we're going to compare each person to themselves. How much did you lose versus how much did the other person lose? How much versus how much the next person? So we're going to be subtracting ordered pairs, okay? So one of the things, all right, is that we're going to change our language a little bit. Okay, so just check to make sure on your paper you have equals, equals, equals. I don't remember if I think I changed them before I copied, but just double check, okay, that you should have equals here and equals here, because there was an old way that it could have been written, but we're going to be using these equals. We're going to have mu d is the expected mean of the difference of your matched pairs. We're working on the differences, all of those subtraction answers, okay? So up top, the mean difference is going to be equal to 0, which means there is no difference. So that's always going to be your null hypothesis. Then we could have, if it's a two-tailed test, it's going to be that the difference is not 0, or your difference is less than 0, or your difference is greater than 0. Now I'm going to explain to you how we come up with these bits here, okay, which one is which. So what we want to first do is just go through like the scenarios, okay, before we do the full-fledged hypothesis test. So for number 1, Chevy wants to test to see if changing the timing belt in a truck is going to increase your horsepower, right? A sample is taken with the truck's horsepower with the old belt and with the new belt. So we're going to do old belt and new belt, or your before and your after, okay? Now what happens is when we're setting these up, you have to add how you're subtracting. You get to make this decision, right? If we think about your before is your old belt and the after is the new belt. LT, sorry, there's my T. Okay, we need to figure out like which way we want this to be, what it should be. If we increase horsepower, then which one of these numbers is going to be the bigger number? If you increase horsepower, then after you should have a bigger number and the before should be the smaller number. All right. I'm a fan of doing before minus after or old minus new or however you look at it every time, like being consistent here, and then you have to think about what this scenario is. Some people can do this without jotting down small and big for the numbers. Some people need to jot it down. It really just depends on you, because this tells us what happens. If you have a small number minus a big number, then that should become what kind of sign? Small minus big should be a negative number. And that negative that you think about is what's going to be here. A negative number is less than 0. Okay, so again, we wrote down mu d is equal to before minus after. Then we thought about, okay, well, if it's increasing horsepower, this is going to be the bigger number. Your new belt will have more horsepower, so it's going to be bigger than this, which means when you subtract them, you're going to get a negative value, which is why I did that the average difference is less than 0. Okay. If we look here, Ben & Jerry's is running a test to see if people who only eat their ice cream, if you eat only just Ben & Jerry's, would you actually lose weight, right? What a great test run to be in. So if you're losing weight, if I do before minus after, which one should be the bigger number? Okay, if the goal is to lose weight, then this should be the bigger number, your before, and this should be the smaller number. And when you do big minus small, that should be a positive value, which would mean a greater than. Okay, because it would be a positive, it would be above 0. Okay, if it just says like different or changes, then that's when it's still equal, not equal, like we've been working all along. All right, so this last one, if we do Super Fitness Company is marketing a new protein shake that's supposed to help people gain weight. So this time if you're trying to gain weight, you're taking your protein shake daily and you want to, you're trying to put on pounds, your before would be the smaller number because you're trying to gain weight, so that would be the bigger number. And if you have small minus big, then that means that you should have a negative value, which is why we would have less than. Less than is still a left-tailed test. Greater than is still a right-tailed test, and so forth. Okay, your formula is here. We're gonna have D bar is your mean of your differences. So we're gonna subtract, in whatever order you put these, you're gonna subtract your problems, okay? So this is the average of all the subtraction answers. This is the standard deviation of all your subtraction answers. You wanna put a little parenthesis here. This is a big fraction where that's in the numerator and this is in the denominator of that fraction. And I'll show you how to put these in your calculator. Your critical value or your p-value, you're gonna get your t-chart or t-CDF with degrees of freedom n-1. And we'll go through those as well, absolutely. Okay, so the first thing we wanna do is we wanna take a look at this problem. Okay, physical education director claims that by taking a special vitamin, a weightlifter can increase his or her strength. All right, so 8 athletes are selected. They're given a test of strength using the leg press. After 2 weeks of training, supplemented with the vitamin, they're tested again. We want to test the effectiveness of the regimen at alpha equals 0.05. So we've got our before weights that they can press and then the after weight. So if you're increasing strength, let's think about this, right? Your before, if you're increasing strength, which one should be the bigger number, the before or the after? Your after, it should be the bigger number. Okay, and this should be the smaller if we're increasing strength. So small minus big is a negative value, which is what we have here. Our mean difference is going to be less than 0. Okay, now what we need to do is we need to subtract. Whatever you write here is how you're going to subtract. You could subtract by hand. You can do 210 minus 219 is negative 9. 230 minus 236 is negative 6. We're looking for all of the differences. We want the subtraction answers. Another way we can work on this is in your calculator. So if I make a new document, okay, I'm going to make a list and spreadsheet. I'm going to come up here and I'm going to call the top one my befores, BEF, okay, for my befores. Oops, I don't want that tab. Get out of there. Okay, and I'm going to type in my befores, 210, 230, 182, 205, 262, 253, 219, and 216. Okay, then I'm going to come over here and I'm going to do my afters. You really gonna get to pick what you want to do. If you want to just subtract them, you can just subtract them. Okay, oh goodness, did it again. Tab down here. All right, I'm going to type in my 219, my 236, 179, 204, 270, 250. Okay, now what my calculator can do is my calculator can subtract it for me. This data set was only 8 points, so it might be faster to just subtract and type in your answers, right? So I said 210 minus 219 is negative 9. I ran out of space, so I'm just going to put it down. 230 minus 236 is negative 6. 182 minus 179 gives us 3. 205 minus 204 is 1. 262 minus 270 is negative 8, and so forth. The other thing you can do, and you'll notice I came down to the second cell here, all right? So if you see, I came down to this second cell in the gray, and you can type in BEF minus AFT, before minus after. That's how I named mine. So when I type it in and I press enter, it subtracts them for me. So these are those numbers, right? -9, -6, 3, 1, -8. It did all the subtraction for me. So you can either subtract by hand and type this in, or you can do what I did, type in the 1, type in the second, and then subtract them and it doesn't matter. But what you need is you need to do one variable statistics for this column. So you're gonna go menu, stats, stat calculations, one variable statistics. You wanna make sure it's wherever your differences are listed. Mine are listed in column C. And here we go. My X bar is -2.375. I'm not gonna round because it's the end of that's just exactly what it is. There's no more decimals. So I'm just using that as a number, okay? And then down here, my standard deviation, you see how it's like huge at the bottom, right? When I put it in the spell. So I rounded to 4.838. I did 3, just so they matched, okay? So when you plug this in, your formula is the average of the differences divided by the standard deviation of your differences divided by the square root of n. So you're gonna go back to the calculator page and you're gonna do a fraction, type in your numerator, -2.375, go down in the denominator, hit the fraction again, you're gonna have 4.838 divided by the square root of 8, and you get -1.39, which is my t here. From here, we do the same thing we've been doing for months now, okay? Your p-value is TCDF. So this is a left-tailed test because we have less than 0, okay? So when you plug that in your calculator, degrees of freedom are n-1, then you get that, all right? That's greater than alpha, so we don't reject, which means we can't conclude that the strength increased after taking the vitamin or the supplement. This is no change happens. That the average of your differences, the average of your change is nothing. There's no change. If your average is nothing, then it's no change. This means that strength increased. Some people are going to do better with the words next to them. So if you don't reject the null, that means we can't say that the strength increased, that there's no change. Okay, so as you're looking at that, you've got those pieces there. All right, so you get to pick your comfort level. If you, like, especially a small data set like this, it's probably just way faster to just subtract, write them down, and then type in what your subtractions were, your subtraction answers, okay? So when you think about it, you just have to be careful. So this time we want a dietitian wishes to see if a person's cholesterol level changed if the diet is supplemented by a certain mineral, all right? Now it's just saying there that it's going to change, right? And I've changed here as well. So again, the key with these problems is they're matched pairs. Person number 1, here's their cholesterol before, here's their cholesterol after. Person number 2, before, after. Person number 3, before, after. So we want to pair them up, right? It doesn't make sense to just average all the befores, average all the afters, and then compare the two average of the groups. We want each person, you to you, you to you, you to you, like comparing them that way. So when you're setting them up, if we do let the mean difference be before minus after, remember you always have to write this down, okay? Then if it's changing just means that it's equal, not equal. It's just that they're not the same. So when you do before minus after, 210 minus 190 is 20, right? 235 minus 170. So if you want to write like the differences, if you have space down here, you can put it at the bottom too. I just wrote too close to that. This one, 235 minus 170 would be a difference of 65. 208 minus 210 is a difference of -2. This is a difference of +2. This is a difference of -1. This is a difference of what? 16? So then you're going to go in your calculator and you're going to type in a list of 20, 65, -2, 2, -1, 16. Just type in your list of your subtractions. Do this, guys. Like, make sure you know what I'm talking about. You're going to have a one variable statistics. When you do that, the average of these differences is 16.67. The standard deviation was, I believe, 25.39. Okay, I know my decimal looks a little funny there, so it's 25.39. So then when you plug it in the formula, it's the average of your differences divided by the standard deviation of your differences over the square root of n. I got 1.61. It's a two-tailed test. You'll see I doubled my p-value because it's equal, not equal, so it's a two-tailed test, right? So you have above, you have below. I got my TCDF, remember degrees of freedom still, n minus 1. I got my p-value to be 0.1684, which means do not reject the null, which means we can't conclude that the cholesterol level changed. All right. So what I want you to do now is I want you to read through this next problem, pause the video, well, let me give you the directions, then pause, right? So we're gonna read through number 3, pause. I set mine up here, all right, as the express lane minus the regular. So there is no before after, but we're pairing up like, you know, the grocery store, sometimes it's really busy and sometimes it's really slow. So we're doing like the 2 kids went in at the same time and they flipped a coin, they split up the lane and they bought the same item. So it's like comparing each day with itself. So it's like this day, express regular, this day, express regular, this day, express regular. So pause, try using this as your subtraction, try to do the problem, and then I'll show you my answers in a minute. Okay, so pause right now, and then unpause, and let's talk about it. If you have express minus regular, which one's supposed to, we're testing is the express lane faster. So if this is faster, then that means that this is going to be a smaller amount of time, and this is going to be a longer amount of time, right? Faster, longer. So small minus long is going to be a negative number. All right, which means that when you did all your subtractions, this minus this, get your answer. This minus this, get your answer. This minus this, get your answer. Put in all those differences. You should have had these as your values for your differences, which gave you this as your answer for your formula. So now here's your p-value. It's a left-tailed test. Degrees of freedom 14 because there's 15 ordered pairs. And we should have this as our answer. But yes, we can conclude that the express lane is faster. All right. So if you have questions, make sure you jot them down. Of course, we're going to practice this. We'll talk about this after class, like in the next class. And I'll see you soon. Bye.